integrate 1 over x squared times square root 9 minus x squared. So that radical there, constant minus something squared, makes me think I need to do a trigonometric substitution. And that's exactly what we're going to do. We just have to think, well, which one should we use? Okay. So since we're looking at something of the form a squared, where in this case a is 3, minus x squared, okay, we should let our x be substituted with a sine theta. Then our dx by d theta will be a cos theta. And as I say, in this case, a is just 3, because it's the positive square root of 9. Okay, so then dx would be 3 cos theta d theta, and quite nicely, this 9 minus x squared simplifies to just a cos theta, so 3 cos theta as well. Okay, so we just state all that off to the side, or we can work it out on the fly as we go. Okay, x gets replaced with 3 sine theta, so we get 3 sine theta squared there. Root 9 minus x squared gets replaced with 3 cos theta, and the dx here gets replaced with 3 cos theta d theta. And the 3 cos thetas can cancel out right away. Okay, so we'll have 1 over 9 sine squared theta d theta. That's now what we need to integrate. I'm going to pull out the 1 over 9. And we're left with 1 over sine squared theta. You could write that as 1 over sine theta all squared. And the reason we do this is 1 over sine theta is a trig function that we should know. It's cosecant. Okay, so we're looking at 1 over 9 cosecant theta squared. Okay, now cosecant squared. Oh yeah, that's the derivative of cotangent. Well, almost. Okay, the derivative of cotangent is minus cosecant squared, but we can change that easily enough. Bring a minus sign outside, so we're free to bring a minus sign inside. Okay, so we get minus 1/9 cotangent theta plus a constant. Great, we're done, right? Well, they gave us the problem in x. We should give it back to them in x. How do we do that? Well, we know that x is 3 sine theta. So we could rewrite that as x over 3 sine theta. Now if we imagine a nice right-angled triangle with an angle of theta here, sine is opposite over hypotenuse. So if we make x our opposite and 3 our hypotenuse, we can then use the Pythagorean theorem to say, well, 3 squared minus x squared, square root that, should be this remaining side. And what do we need? Cotangent. Cotangent is adjacent over hypotenuse. So negative 1/9 root 9 minus x squared all over x. Or we could say minus 9 minus x squared square rooted all over 9x. And we don't forget our plus c. And that is our final answer. Okay, so some trig substitution and then some work with right angle triangles at the end to get everything back in terms of x, which is exactly the way we like things.